So far, we have studied 5 different elements of symmetry. First one was identity, which was encompassing all the points in the molecule and around it. Second one was axis of symmetry, which was composed of one line. Means what will be the common in that identity and axis? A line will be common. Third one was plane of symmetry. It is a lamina. It is a cutting of the molecule into equal halves. So what can be the common in the plane, line and identity? Considering all possibility, at least one point will be common. Fourth one was center of inversion, a point present at the center of the molecule. Means what is the common among all? A point is common. Fifth one was improper axis of rotation. It also encompasses dual mode elements. One was axis, another was plane. Among all those 5, one thing is common, and that is point. So there is a point in studying that point. All operations do pass through one point. Means operations are collected at one point. That point where all operations are grouped, all elements are grouped, which can describe all possible operations. It's called as point group. Out of the various types of point groups, I like to discuss here only 2 types of point groups. One cyclic and other dihedral. How to know them? How to categorize them? How to assign them? That we are studying. For that, a basic knowledge of principal axis, subsidiary axis, types of planes, horizontal, vertical or dihedral, that much concept at least should be known to you. Now I tell you one formula. Principal axis has with one order, say n is a order. Subsidiary axis, number of subsidiary axis, that may be the any number x, y, z or n also may possible. And planes we label as sigma h means horizontal, sigma v means vertical, sigma d means dihedral. So rule is, if order of the principal axis n is equal to number of subsidiary C2 axes, then point group type is dihedral means capital D. Otherwise, time being remember capital C. I repeat the formula. If order of the principal axis n is equal to number of subsidiary C2 axes, then capital D or else capital C. This is the first point of distinguishing the point groups or labeling the point groups. After the C or D categorization, we need to represent order of the principal axis. Just now I said, what was the order of the principal axis? N. So capital C or capital D that we have sought out from the operations possible, followed by as a suffix we need to write order of the principal axis N. So what will be the representation now? If it is a cyclic kind of point group, then Cn will be the representation. If dihedral kind of point group, then Dn will be the representation. But just wait, yet we have not completed the labeling. Afterwards, types of plane present in the molecule will decide the further nomenclature. So 3 planes, horizontal, vertical and dihedral. Among them, a superior plane, powerful plane, which we need to emphasize, which we need to mention is horizontal. Second is dihedral and third one is vertical. While arranging in a group, arranging in a collection or gathering the all operations, we were considering vertical first, then dihedral. But here while labeling, dihedral will come first, then vertical. That is a priority. Means, suppose if all three kinds of planes are present, then you will label it as H, horizontal plane. Alone if horizontal remain present, then there is no question. We need to mention H there. Where should we mention that? That Cn or Dn that we found, no? There H will follow that N. So it can be now CNH or it can be DNH. But suppose horizontal plane is not there. Only two planes are there, vertical and dihedral. Then who has a priority? Dihedral has the priority. So there we will represent it as CND, which is not possible but understand, and other DND. For cyclic point group, existence of dihedral plane is not possible. It means C and D is not possible symmetrical point of view. But suppose dihedral plane is not there, horizontal plane also is not there, only vertical plane is there. No option, no choice, we need to represent it as V. So it can be CNV or DNV. Here, existence of only vertical plane impossible for dihedral point group. It means DNV as a point group is not possible symmetrically. The point groups which are in your syllabus are C2V, C3V, C2H, D3H, C infinity V, D infinity H. So among these C and D category with vertical and horizontal planes, point groups are included in your syllabus. Dihedral plane is not included, but I had informed to you what is that dihedral plane. Now here point of interest is point group C infinity V. A name of the point group, label of the point group tells us a lot. What is the significance of that label C infinity V? Which principal axis may present there? Yes, C infinity. And the name of the plane, type of the plane also is mentioned in that label. So which plane is present? Vertical plane. So C infinity V tells us the molecule will be with C infinity as a principal axis and there should be vertical plane. Now tell me, will there be a horizontal plane? Absolutely not. Why? If horizontal plane would have been there, then label should be H. V will not come. What about dihedral plane? That also should not be there. It means we have to choose such a molecule where C infinity axis will be there and only vertical planes. Now C infinity axis means what will be the nature of the molecule? Of course, linear. So from this point group label, we got one idea, molecule should be linear, C infinity axis and vertical planes. Now let us see the example and the possible suitable elements and operations related to those elements one by one. Here is an example of hydrogen chloride molecule. By white color, hydrogen atom is represented and by green, chlorine atom is there. Linear molecule, simple molecule. But elements and possible operations are little complicated. You need to understand them very wisely. As usual, which is a primitive operation? Which is a trivial operation? Identity. So I am representing identity first, comma. After that, I need to represent that axis who has highest order. In this molecule, there is only one axis, which is along the hydrogen chlorine bond. And what is the name of that axis? Yes, by minute or very fine, very less, y infinitesimally smaller angle rotation, I can find the similar structure. So name of that axis is right, C infinity. If we follow our usual trend, then how many C infinity operations should be there around that C infinity axis? There should be infinity. But what representation you are getting there? 2 into C infinity in bracket phi. What is phi there? Phi is a variant angle. And now see the range of that phi very carefully. Phi is greater than 0 but less than pi. Pi means 180 degree. And there double C infinity with variant phi is mentioned. So reason behind that I discuss in detail while discussing the excess of symmetry. By very small angle we are performing the rotation operation. And when we talk about four quadrant, when we talk about various angles, measurement up to maximum 180 degrees is sufficient for us because we can move in clockwise direction or anti-clockwise direction. But mind well, we are not changing our direction. We are changing our position. We can measure in anti-clockwise direction from inward portion of poles. Poles means the arrows of the axis. Or we can measure in anti-clockwise direction only from outward portion of the poles. So within poles and outside poles, these are the two positions of our measurement, but direction of measurement will not change. Direction of measurement of angle we will keep positive only, so that only up to 180 degree angle measurement is sufficient for us. If the concept is not clear, you can go through the video of axis of rotations, proper axis of rotations. Now here I am going to double that, because if any operation remains, inverse of that operation should be there. If I measure 60 degree, then inverse of 60 degree means minus 60 degree. In reverse way that we are considering from opposite position. Minus 60 degree means in general sense what is angle? 300 degree. In spite of saying 300 degree, we will say it is reverse way, other way, changing the position, 60 degree. So only up to pi measurement is sufficient. But pi is not considered. Phi, variant angle phi is less than pi. Why pi is not considered? Because I am doing repetitions of those operations. And if I repeat pi, then double time it will be there. Two times no operation is allowed. Therefore, it is less than pi. And why is it greater than 0? Why is not equal to 0? Because rotation by 0 degree means it is identity. And identity already we have considered. We should give fundamental basic right for the identity. So we are not considering rotation by 0 degree and rotation by pi here in this C infinity. But we need to consider at least one time pi. Therefore, after C infinity with variant phi, I represented C2 operation. That C2 operation is a part of C infinity operation. Separately it is represented, and this is a convention. This is a proper mathematical way of presentation of operations for C infinity axis. Actually infinite number of operations are there. Don't misunderstand, only two operations are there, because variant is phi and variation is from more than 0 to less than pi. Infinite possibility there are occurring. So way of presentation for operations around C infinity, are they clear? Afterwards, there is a no center of inversion, there is a no horizontal plane, there are no improper axis of rotation or respective operations, but there are vertical planes and number of vertical planes are infinite. Whatever the variant angles are there, no, by which we cut the molecule, then infinite possibilities are there. Here variant angle is per phi and the range of per phi is equal to or greater than 0 but less than pi. See here the difference in phi and per pi. That per phi where it is equal to 0 means we are considering the plane along xy plane. If that plane we are considering, then that plane encompasses angle of 180 degree because plane can have that linear representation. 180 degree pi angle is covered, so in that 0 degree pi also is covered. Therefore purposely in order to avoid repetition, per phi is less than pi but per phi is equal to 0 or greater than 0. By small variations also we can get infinite number of planes. Now question you will be with, why doubling is not done? Are we not repeating? Students, we are talking about planes. So the as like 0 can cover pi, 0 can cover 180 degree. Likewise 90 degree can cover 270 degree. Are you following? 120 degree can cover minus 60 degree, means reverse way 60 degree. There is no need of repetition in case of plane. And one plane, one operation. Representation is infinite sigma v in bracket per phi, where per phi is greater than or equal to 0 but less than pi. Is it clear? It is the other example. Carbon monoxide. Structure is same. Only two atoms are there. One carbon represented by gray color and oxygen represented by blue color. And between them three bonds are there. But number of bonds are not going to make a difference for our symmetry. Arrangement matters here. And symmetry, if it is the same, operations will be the same. So which operations are possible? Identity. Double the C infinity operations with variant angle phi, where phi is greater than 0 but less than pi. And that C2 axis, a coinciding axis to C infinity axis. Only one operation that we are considering. That's a C2 operation obtained from C infinity. Likewise, we can understand. Plus infinite number of vertical planes with variant angle per phi, where per phi is greater than or equal to 0 but less than pi. Total number of operations h is equal to infinity. That is the meaning of this structure and collection of operations. Let us see one more example which comes under category of C infinity V. It is HCN molecule, hydrogen cyanide. Three atoms are there. One hydrogen, second carbon, and by red coloration nitrogen. Between carbon and nitrogen, three bonds are there. The structure is linear, but there is no any horizontal plane. Point group is C infinity V. How can I represent the possible operations for this molecule? Identity, comma, double the C infinity operations with variant angle phi, where phi is greater than 0 but less than pi. C2, a coinciding axis obtained from C infinity, comma, infinite number of vertical planes with variant angle per phi, where per phi is greater than or equal to 0 but less than pi. So it is somewhat different example, but the point group is same. Purpose to give you these examples is the concept of point group, concept of arrangement of atoms, concept of possibility of various symmetry operations is to make clear. Is this example clear? Now let us come to the task of homework. Two questions are for you. The first question, why do we consider the variant angle phi that we were considering for C infinity axis is greater than 0 and less than pi? Means why is it not equal to 0 or equal to pi? I had given you answer in this video as well as in the video of proper axis of rotation. But I want explanation from you in comment box. Second question is, we consider per phi a variant angle used for vertical plane is greater than or equal to 0 but less than pi. Why is it not equal to pi? Are you getting the second question? Answer for second question also I want in the comment box. I am waiting for your answers. Let us study in next part other point group, last point group, D infinity H.